Welcome. We're taking a peek today at the preview, getting you ready for quiz 3 tomorrow. So hopefully this will help you get prepared for that in a good way. We're going to start with some stuff that reviews back into what we were doing before, even our favorites, the solving for an equation, but we'll get there in a moment. First of all, we've got the fractions, and we've talked about this several times. We'd like to use a least common multiple here to multiply through, which basically we'd look at 2, 3, 4, and 6 and say, okay, if I were to count off by 2s and 3s and 4s and 6s, you know, what's the first number that would come up they'd all have in common in every list? Well, that'd be 12. But some of you have had some difficulties with that. So what we've talked about doing is the ability to take 2 times 3 times 4 times 6, well, that's a little bit bigger, 12, 24, 144, and multiply through by that. Now, definitely going to need some calculator help when we get to some numbers that are that large. So let's pull the calculator up here. And again, we're multiplying times the numerator, so times 7. And then we're dividing by the denominator. So I've got 252x. Then I would go through and I'd do 144 times 1 is 144, divided by 3 is 48. And again, using the calculator on this, not a bad thing. When I get over to the other side, now I have to be a little bit more cautious here, because now I have a negative 5 over 2. And my other thing I want to watch is when I'm doing these. So negative 5 times 144, and then divide by 2. Notice the negative only went on one of the values. So negative 360x, and then 144 times 3, and then divide by 6. And there go all of the fractions. Once that occurs, my job, of course, becomes to get all of my x's to one side. So I can add the 360 over to this other side. So if I add 360x, again, whatever I do to one side, I have to do to both. We made a little tight on room here, didn't we? That's okay. But it also lets us see that sometimes we're going to get fractional answers and that's okay. I'd add my 48 over. We'll put our answer above it. So I add my 48 over, gives me 120, and then I'm going to divide. So I'm like, okay, I might get a fraction here. So little things, like I'm dividing both sides by 612. So I type in 120 divided by 612. Okay, and I get this funky decimal, but let's see if we can get it back into fraction form. So again, when we're doing that, a lot of you have a fraction button on your own calculator, but if you're using one of the ones in here, we do math, and then we hit enter twice. So my answer would be 10 over 51. So you can get funky answers. It's not always going to come out something nice like x equals 2 or something like that. Then we get to our nemesis, the formulas. Remember, our goal all the time is to work on getting that variable term that we're being asked for alone. If there's fraction issues, we'll go ahead and we'll take care of that. So the opposite of dividing both sides by 4, x that is, would be to multiply by 4x. Whatever I do to one side, I have to do to both. Okay, so 4xy on the left, and the fraction's gone on the right. And then again, all I have to do, remember, I'm trying to get b alone. Okay, well right now I'm minusing 3a from b. So what's the opposite of minus and 3a? That's right, hopefully somebody said plus 3a. Well, I had that pause in there. So 4xy plus 3a equals b, and b solved for. I'm done. Nothing too bad. But it always is about when you're solving equations for a variable. Get whatever's furthest away out of there first by doing opposites and work your way up. So then we get to our arch nemesis. This thing we've seen, like, I think this is time number 7 now. Solve for p, but there's 2 p's here. If both terms have a p, I can't add it over. P can't be part of my answer. Okay, I can't divide it out. The only way I can get it where I need to is to factor a p out. They both have a p in common. Make myself a set of parentheses. And then I just ask myself, okay, p times what gets me to 4mp? Well, I already have the p part. So p times 4m would give me 4mp. Okay. P times what would give me negative p? A negative 1. And just like that, I only have one p now that I'm trying to solve for. And since I'm trying to solve for this, and I'm multiplying it, that's what the parentheses mean, times 4m minus 1, what's the opposite of multiplying by something? Dividing. And did I mention how good of a study tool this is to be able to get ready for a quiz, since you're basically seeing what a copy of it is ahead of time? Yeah, just mentioning that. This video is available online. Blanks of the review are available, so if you do this now, if you really want to see if you know what you're doing later, maybe you either grab an extra copy if there's one over there, or maybe you just print an extra one off the website and then go ahead and see if you can do it. And this is like doing your answer key. Just a thought. The tools are there. All right, 4 through 6. Identify the vertex, the slope of the branch, and graph the following. Okay, reminders. When we're doing these, here's my general form of the equation. And my vertex is the h and the k. So for instance, on number 4, if I want to look at it a little bit more in a form that looks like the completely worked out form, that would look like this. So my vertex, I can't have negative 0, so it would be at 0, 7. That would be where my first point goes. Once I have that, okay, the slope of the branch is just whatever my value is in front of my absolute value. So my a is negative 3. And again, what's that mean? Well, basically, what that means is that it's going to open downward. And when we talk about slopes, remember, it's our air quote slopes. Because normally, if it was just slope, we'd go down 3 and over 1, and then we'd go down 3 and over 1. And we keep going and we get a line. But we know these are supposed to look like V's. So instead of just doing it that way, we also go down 3 and left 1. We do it both directions. And then connect the dots, and I get my absolute value graph. And we're also going to come back to our things with domain and range. Now again, just reminders on these. Domain. Domain is my x values that are from left to right. Okay, so if these arrows are going forever and ever and ever and ever out and to the left, and forever and ever and ever and out to the right, we talked before about how my domain on all of these is always going to be negative infinity to infinity. That should be the easiest question that you ever get on any of these. Now my range is my y values from bottom to top. Okay, so the bottom of my graph, well, I can't really see it because these arrows mean it goes down, 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 down forever. So it starts at negative infinity. But does it go up, 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 up forever? Not quite. It stops up here at 7. So that's how I'd write that in. And that's it. So whenever we're doing these, my job's always, again, to find the vertex first and then work on those. So again, my vertex here, and we've talked about this before, this is the tricky part. When I'm getting my x value here for my vertex, it's not positive 2 because the formula says the opposite of what I see. I see positive 2, so I'm going to use negative 2. But I do use exactly whatever value is outside. Okay, so negative 2, negative 3, a nice big dot there. Now, my slope, my a value, I don't see any number in front of my absolute value, so what number is supposed to be there? All right, somebody hopefully has shouted 1 at this point. So 1 means we're opening upward. So from here I go up 1 and over 1, and I do it both directions, and then I go up 1 and over 1 both directions one more time. Connect the dots. Absolute value graphs always look like V's. Okay, never will they look like a straight line. And then my domain and range. Now remember, domain, that's the easiest question on the whole thing. It's always just negative infinity to infinity. Now what about my range this time? Since my domain's the easy part, the range I got to think a little. Is there a bottom portion of my graph at y? There is. It's right here. But again, it's y. So think about it to the y-axis here. It looks like we're at negative 1, 2. Looks like we're at negative 3. Okay, do I have a top boundary? Not really, because that arrow means this is going forever and ever and ever and ever to the top. And I'm set with that one. So these really aren't bad. I just have to get used to a couple of things. The only way you get used to them, practicing them. So last one. Vertex. Cover mine up for a minute. I want you to try and figure out what the vertex should be on this one. All right, are we ready? Opposite of negative 3 is positive 3. Keep what I have on the outside. So 3, negative 1. My a value is 2/3, which means we're opening upward. So we got that. So let's see. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 2, 1, 2, 3. There's my V. Notice it opens up wider because I have a fractional a value. So last part of this. Can anybody tell me what the domain is? I hope so at this point. Negative infinity to infinity. Okay, what about my range? What if we're going from bottom to top? What's my lowest y value? Lowest y value looks like it's negative 1. And then the arrow is up forever. So we're good to go. And again, if this is one of those sections that kind of gets at you, you've got the YouTube videos to go back and look at. Shoot, you can look at these again. Maybe if you haven't done the homework, now you know what you're doing now. So you can go back and get that situated. I'd hope so. So then we're going to move up a little here. We're going to move into piecewise. A little bit algebraically first. And again, I'm going to make mention. This is the key for all of these. I have to look at this part first because that tells me what I'm plugging into. For instance here, this f of 1, that's my x value, the number in parentheses. So if it's 1, is 1 less than 1? No. Is 1 greater than or equal to 1? Yes. So since that's the case, this is the expression I'm going to use. I'm going to use parentheses when I plug a value in. If I owe somebody $1, I borrow 3 more. Now I owe them $4, and I'm done. So no panic in here. Okay. Negative 2/3. Is a negative number less than a positive 1? Certainly is. So I'm going to use the top one. Don't freak out just because you see a fraction. There's ways to deal with this. Okay. If your favorite thing in the world is not dealing with the fraction, we have ways of helping. So check this out. Notice I'm using parentheses when I'm dealing with a fraction. I just use divide for that part. So again, it's just the details, making sure I'm taking everything cleanly. Okay. And then plus 2, and you can just use math, enter, enter to get the simplest form. Okay. If you're comfortable with fractions, go ahead and work that out. But if you're not, let the calculator help you. And any scientific calculator has a way of doing this. But that's what we're trying to get to. And then finally, f of 4 is 4 less than 1. No. And again, how do I know this is less than? It's less than when the arrow points at x. It's greater than when the arrow is eating x. Okay, no matter where x is, we can always figure that out. So 4 is greater than 1. So I'm going to plug this into the bottom equation. Negative 4 minus 3 is negative 7, and I'm good. Now we hit our arch nemesis, piecewise. We've talked about graphing and erasing. We've talked about going straight to a chart. We talked about doing the combo plan yesterday. I'm still going to stress for a great number of you one of the last 2 plans that we worked with. So here's what I'm going to do. I'm going to do one of them using strictly the table and one using our combo plan from yesterday. So we're going to start with the table with our top one. If you're going to go table, when I go to make my little table, this number is the number I always start with. That is my pivot point. That is my start. I start at 2. What does this say, though? X is less than or equal to 2. Less than. If I start at 2 on my number line, I start going left, what numbers do I get to? 1 and 0. So those will be my other 2 values I plug in. And at this point, I'm just going to plug them into this and see what numbers come out. So negative 2 times 2 is negative 4, plus 4 is 0. Negative 2 times 1 is negative 2. Plus 4 is 2. Negative 2 times 0 is 0. Plus 4 is 4. And the only other thing I got to figure out right now is if that first dot at 2, 0 is going to be open or closed. So I look at my arrow. Okay, is this going to be open or closed? Hopefully you said closed because they are equal to. So I'll make that mark as my reminder. Go to 2, 0, make a nice big old dot. Go to 1, 2, 0, 4. Start at my first one, start at the 2, and connect the dots. Okay, not starting at the intercept, starting at 2, the first number I dealt with. So that's one way we talked about working this. If you're comfortable with that, do that for the second one as well. But we talked a little yesterday about what I could do just if I wanted to use 1 point and then combo. Okay, if that's the case, when x equals 2, that's where I'd start with an open circle because it's just greater than. I would plug my 2 in, okay, because this is going to be my starting point. Negative 1/2 times 2, well, half of 2 is 1, so negative 1 minus 2 is negative 3. That's my y. Okay, so I'm going to start at 2, since that's the x value, negative 3. So 2, negative 3 with an open circle. So if I'm doing the slope method from here, I'm going to start there and I'm going to try to figure out, okay, x is greater than 2. Greater values go to the right. So I want a graph to the right of this. So if my slope's -1/2, it means I go down 1 and right 2. And I'm going to the right. Sweet. Down 1 and right 2. Connect the dots. So that's my options with this. Table's cool. Plug in your first dot and then do slope is cool. If some of you are still graphing and erasing, you can, but again, be careful on where you start. Otherwise, this works out pretty nicely for us, okay? But if you need more practice, again, go to my YouTube and just search piecewise or look at the playlist and find it. Maybe we'll do a little review of that in here in the video too at the end, how to use Mr. H's page a little better. So we'll flip over. Okay, solve by showing all work. State the solution in interval notation. These are absolute value. There are going to be two answers. Do not just solve what's there. You'll drive me insane. First job when we're doing any of these, isolate the absolute value if it's not. That +4 has no business here. Don't split this up already until that's out of there. Okay. Once it's isolated, once the absolute value is on the side by itself, now we're ready to do stuff to this. My absolute value is less than. That's an and statement. What's that tell me? It tells me the graph should be coming together like this at the end. So how does Mr. H normally do this? Well, let me show you. Mr. H on an and normally will add another arrow and just change the sign. I have people ask, can I split them? Sure, but I like this better because it lets me kind of think about what things should look like. My goal is to get X alone in the middle. Which I have accomplished. Now I know. Does it ask me to draw a graph? No. Am I going to draw a graph anyway? Yes. Why? Because if I see what's going on, it's more than likely going to get me to do the correct interval notation. X is less than 11. Because remember, X is the diva. It's always about X. So X is less than 11, which means I start at 11 and the less goes left. Then don't be an arrow follower. It's not about the arrow, it's about X. X is greater than 1. Greater than goes to the right. And this ends up looking the way it should, and also makes my interval notation easy. Furthest most point, it's always left to right. Left is at 1. Ends right here at 11. That's what my ands look like. That's what their interval notation looks like. That's what the graph looks like. We start putting these things together based on the arrow. Same idea on number 12, except now the absolute value is being eaten by the X, which means it's an or statement, which means typically that means we copy down what we see for the first inequality. And what are the two things that switch for the second one? Do I change this to a positive 3x? Oh, I better be hearing no's being shouted throughout the room. Never touch what's inside the absolute values when you're starting these. I'm gonna flip the arrow and change the sign of my solution part. That's it. Once that's done, we just solve both of these. Again, both of them, because there's two answers in interval notation. Subtract my 1. I'll do that on both of these. Okay. So what's my last step on both these? And no, it's not time to go. Divide by -3. Okay. So what happens, what other special thing happens when we divide by a negative? The arrow flips. Got to remember that part. The only time the arrow flips is if I multiply or divide both sides by a negative. Not just because I see a negative, but because I actually multiply or divide by it. If you are more comfortable with decimals at that point, if you want to use -0.67 and positive 1.33. That's okay. Again, I'm going to draw a picture. And again, if the decimals make more sense to you, that's okay. So let's see, ORs. What are ORs supposed to look like? Oh yeah, they're supposed to go out from each other. Both start with O. So let's see. X is less than or equal to negative 2/3. Okay, that's a bracket. Less than is left. X is greater than or equal to 4/3. Greater than, okay. And these are the ones with the really big interval notations. Why? Because when we go left to right, left is forever to the left. Up until negative 2/3. Because then it stops. But then to let it know it starts up again, we use the U for union. Come down here, we start up again. 4/3 and off forever to the right. Get my interval notation. So then we get back towards our functions. So what we're going to do here, graph an example of a function, so it's got to pass the vertical line test, that has a domain, so x values from 0 to 5, and y values from negative 1 to 4. Now I can't just draw 2 lines and make this work. It won't pass the line test. So instead of doing that, we've talked about before the easiest way to do this little trick. What I'm going to do is I'm going to take my x and my y, the first ones, make a coordinate point. I'm going to take my second x and my second y. Make sure you're putting them in the right order. That matters. And what I can do then is, if I plot those 2 points, so 0, negative 1, and 5, 4, still not time to go, and just connect the dots. Don't draw a line through. No arrows. Just connect the dots, and you're done. Because my x values go from 0 to 5, like they're supposed to. My y values go from negative 1 up to 4, like they're supposed to. So that's all I need. If you want to do something funkier, you can, but it's really not necessary. So let's see what else we got. Graph an example of a function that has a domain of, negative infinity to infinity, and a range of negative infinity to 6. Now let's think about that for a minute. Let's flip back over for a second. Because I remember things that look like this. Let's look at this one more time. Domain of negative infinity to infinity, so that sounds like one of our v's, okay? And a range of negative infinity to 6. Here's one where I was negative infinity to infinity, negative infinity to 7. Looks like it just went up. Okay, I can do this. Let's flip this back over. So my range goes from a bottom of negative infinity up to 6. Wonder if this would work. Let's see. I hope it does. I just did it in pen. Negative infinity to infinity for my x's. Forever to the left, forever to the right. Okay, that makes sense. In a range of bottom negative infinity, yes, up to a top positive a 6. Hey, all right. So that's all I've got to do. And if I'd switch those around and have 6 to infinity, I'd start at 6, and I'd go up. Okay, so just think about it for a minute. But once you see this, okay, automatically think it's a V of some sort. Just got to play around with it a little bit. That's all, that's all, that's all. Then to our most recent stuff, factoring. Okay, remember from your half sheet, rule number 1, the golden rule. They have something in common. If they do that first. 4 and 24, I can take out a 4. Can I take out anything else? They have anything else in common? Yeah, I think they both have an X. Okay. Parentheses. Okay, now I just ask myself, 4 times what gets me to 24? Okay, that's 6. X times what to get to x squared? I need an x. And then I notice it's 4x and 4x. It's just the minus. So if I multiply by -1, that would get me back here. So if I would do the distributive property, I'd get back to that. That's all I have to do on that one. 16's like our diamond problems because there's no number in front of my x squared. So just a reminder, I'm looking for two numbers that multiply to -28, add up to -11. Now remember, there's all kinds of hints here waiting for you. Okay, multiplies to a positive, which means they have to both be positive or both be negative. Well, how do I know? Right here. If they're going to add up to negative, it means these are both going to have to be negative. So I need two numbers that multiply to 28 and add up to 11. Hopefully at this point somebody said 7 and 4. -7 minus 4 is -11. Negative times negative is positive. Make my parentheses, put my variable in first, and then just copy the values I have there, and I'm set. Next ones are difference of squares. 25 and 64, we've talked before, we've got to know our squares, at least to 10. So I'm like, okay, 25, so let's see, right to parentheses. What's the square root of 25, or what do I square to get 25? 5, and I put the variable with it. Okay, what do I square to get 64? What's the square root of 64? 8. Put a y with those. And then what about signs in the middle? If you multiply something and you want to get a negative, one of each. And I'm done. Now, our last one. And again, I'm split with some of you on how you do this. For my guess and checkers, you keep guessing and checking. For my slide and divide people, you've got enough room to work with here, because you're not going to need a lot of room on the bottom. I'm going to work to the side here, actually. So I can kind of let you see, I'll work right on here. Shoot, I can do it if you can. Okay, slide and dividers. 6 is sliding. Remember, it slides down to the end, we multiply it. So 5 times 6 is 30. Now it's a diamond. That's kind of cool because I'm good at those. So I need to multiply to get 30, add to get -17. And just like always, there's clues here. Multiply to get a positive, but they're adding to get a negative. They both have to be negative. So now I just got to figure out what multiplies to 30 and adds to 17. So let's see here. 10 and 3 is 30, but is 10 plus 3 17? No. 6 and 5 is 30. That doesn't add up to 17 either. Maybe I should just quit or not. Okay. Well, let's try again here. And if I have to, I can even go to the calculator if I need to come. Oh, 15 and 2. Okay, 15 and 2. Whew. It took me a little bit, but it was worth it. I got there. Now, am I done? No. Because remember, it's slide and divide. Divide. Now, remember, we try punching these in if we're not sure if they go in totally. Let me move my calculator here. Excuse me for just a second. Sorry about that. So, I look and I say, okay, 15 divided by 6, here's the way I'd do it. I wouldn't even mess around with the other stuff. I'd just do math, enter. Okay, 5 over 2. X minus 5 over 2. Let's do that for the other one too, just to make sure. Because 2 divided by 6 isn't 3. I know some of you are thinking that. 1/3. Okay. We always got to simplify the fractions before we do this last part. If it still ends up a fraction, and these both did, just slide those denominators back to the front. And I'm done. So we got to find some method. If you're not one of my mental math people, that is your option. That's the simplest way to make it work. And then finally, describe how the graph of the function is related. In other words, what are the shifts? And we've talked about this before, but we're going to make note of all of them here before we write this. When we're thinking about shifts, okay, Okay, we're back to the original here. Here's what everything tells you. This number in the absolute value tells me whether I'm moving right or left. But again, it's the opposite of what you think. Right is negative, left is positive. And then for my k, that tells me up or down. It's like my y. But those get to be what you'd think. Up is plus and down is minus. So all I'm asking you is if there's shifts or flips of things that we make note of them. For instance, what's this plus 9 in the absolute value tell me? It tells me there'd be a shift of left 9, and that negative in front tells me either that this flips, or you could say opens down, or I don't even care if you draw me a picture that it's going to go down. My V is going to go downward. Any of that's fine. Okay. Second one, not as complex. What's the minus 2 in there tell me? Tells me I'm going right 2. What's the minus 1 on the end tell me? I'm going down 1. This, again, you basically have a copy of the quiz in your hand right now. If there are questions that you're looking at after this going, if Harty didn't do it, I don't have a clue. You need to go back and look at your notes, look at the videos, look at the homework if you've done it, and try to make these things work out. Okay? So just again, I'm going to give you a heads up here on how to play around with my... Okay, just a reminder, here is my YouTube page, Harty Math. Type it in at the top if you're just sitting at home and haven't favorited me yet or subscribed. If you're looking for something specific off of what we're doing besides this video, if you go to playlists, click that. We're in Algebra 2, this is Unit 1. And anything you would need is here. If absolute value equations are driving you crazy, hit this and forward through me to some places that you're having some issues with. If the formulas are your deal, click here, kind of see what's going on. Okay? If step functions are your deal, okay, let's take a look at this for a minute. Let's say step functions are my deal. So I'm going to go ahead, I'm going to click this. Now, do I have to sit here for 17 minutes and watch this? No. I can kind of watch the little screen down here at the bottom and say, okay, let's see. Let's find something. Let's move a little more forward. That doesn't look any fun. Nah. We don't want those. Oh, piecewise. That's what I wanted. See, I started looking, I'm like, that didn't look like anything that was fun, so I want to fast forward here. So I move a little forward, and I get to a part where I can start watching to see, okay, this is when we were erasing the line. Well, I don't do erase the line thing. That confuses me. So let's see if Harty does tables somewhere. So you're going to do tables on this. And you notice I'm doing this, and I'm not necessarily finding exactly the way I want this right away. I'm like, well, dang it, he's doing that on all of these. Okay, well, that's not working for me. Hang on a minute, because he's got to have some more help here somewhere. So let's see. Piecewise revisited. Okay, let's see. Is this going to help me anymore? Let's look. Oh, look, now he's doing the chart thing. He's explaining. Okay, maybe I'll just watch this for a couple of minutes. You don't have to put a monster view of everything in. Okay? That's what I'm trying to get some of you to understand. Okay? Factoring revisited. Maybe factoring's my issue. Okay? There's more piecewise again. Dang, he does a lot of piecewise stuff in here. But let's say factoring's my deal. So I come to the factoring. And again, Harty goes over the different things I'm looking at. Maybe I'm having trouble with difference of squares. Maybe I'm having trouble with some other stuff like the diamond. It's all available to you if you want it. Okay? And that's all I'm basically going to say. So hopefully you're ready and raring to go. I hope so. If not, stop in, ask me a couple more questions, and we'll get after it tomorrow.